開くリスクライブ開発の未来、クロスツールチェーンと最適化技術、よろしくお願いいたします。
Thank you. Thank you. So my talk is about software ecosystem. So there is no cheap photos in these slides. So I hope everyone can relax and just here I'm sharing my story. So my name is Wei Wu. I'm a co-speaker, and I have many titles or hats. And don't worry. So I will tell the story one by one. So how I met RISC-V and get to here. So I serve as many volunteer job in the open source community, including but not limited to the RISC-V. I was a compiler engineer guy, so and do some research. So I try to get some research jobs in the academia. So basically, this is all the titles. And so first, back to about 10 years ago. So I was a PhD graduate trying to get some performance improvements on the Mozilla Firefox. There's a JS engine called SpiderMonkey. And back into 2016, I tried to use the machine learning and the deep learning, try to improve the performance of JavaScript. But unfortunately, not succeed. So I failed, and I feel that it's hard to get the degree. So I dropped out, and I moved into a startup, which trying to build indoor autonomous robots. So they has 2 arms. So, but remember that's 2016. So the hardware and the software is hard to get some real practical usage. So, but anyway, we got some fund from VC. So, and also I worked as a partner, a part-time deep learning trainer at that time. So you know that I have some knowledge about machine learning and a practical experience. And but at that time I said, oh, there's no fundamental mathematical. So given that I'm a mathematical bachelor degree, so that's really I have. So since there's no fundamental changes or the improvements, breakthroughs for the deep learning, so I quit. How stupid I was, and So anyway, I joined a robotic company and trying to get in touch with the fancy technologies at that time. And that time I met RISC-V. 2 people are very important to me. So they basically introduced RISC-V to me in different. The left is Alex. So basically he created the RISC-V China community, and he hold a lot of meetups and do some weekly reports, newsletters to the Chinese audience and the Chinese engineers, both in hardware, chip makers, and the software, especially the compiler engineers and OS engineers. And second is Professor Yungang Bao, who is a founder of the Open Shanghai project. You can search on GitHub. And also the One Student, One Chip program I will introduce in the later slides. And so I was in the robotic startups, and in the 2018, I joined, and I sponsored a RISC-V day in Shanghai. So at that time, and I met a RISC-V ambassador, Wei Wu. And so Wei Wu is the person who introduced me to the path to get my full energy and passion to the RISC-V world. And he also the man who introduced me to the RISC-V ambassador. I am also a RISC-V ambassador now. And he asked me to share the screen here. So basically, we basically in software ecosystem, we have lots of improvements, new announcements, and breakthroughs almost every week. So this week, we will announce a new breakthrough supported from the Red Hat company. This you can treat it as a formal announcement and a very big event. Maybe 10 years later when we look back, so it's a big event in the RISC-V history. So, 5 years ago, back in the time to 2019, so 5 years, I back to the Institute of Software, Chinese Academy of Science, where I tried to get a PhD and drop out, and I founded the PLC lab. The reason is simple. No very ambitious or the high abstract goal. So basically, the startup, I was CTO and ran out of money. So I had to find a new job. So that's basically the reason. And the word out of money, it happens 3 or 4 many times in the rest of the journey. So I back to my area of what I'm really good at, compilers, and I think very special to me. So the community building. So I'm very good at to organize and to bring up a technical community. So I was a co-member of the compiler community in China back in 2009. Basically, I have 10 years of experience. So but in order to get some more funding, so I have to set up an ambitious mission and vision. So and I think that's true. I need to do that. I truly believe that. So and at that time, so I have enough knowledge about RISC-V, and I see that RISC-V is highly maybe the future of computing. So at that time, so I think though the compiler, is a very old open source communities and technique area. So if you want to enter a new compiler community and to try to get your patch accepted, so it's very hard to get otherwise, except for the RISC-V backend, there's a lot of features so which had been implemented in hardware, but not supported in software, especially basically the kernel and the compiler. So that's the natural way or the easiest way to let a new engineering team which get funded and to get his reputation in the open source community. So basically now, in roughly in 1 or 2 years, so the PLC lab I founded, and I'm a project director now. So had a lot of, I never say that enough patches and contributions to almost all important and fundamental open source engineer and compiler projects and simulators projects and language virtual machines. So the mission, so I have to introduce the mission of a PLC lab, which may not relevant to the Kubuds, but trust me, that's closely relevant. That's the path how I get here. So the vision of PLC lab, first, we want to open source leader in compilers, and we want to focus to guarantee the infrastructures has enough engineers to maintain and develop new features that demanded by the chip designers, and also the ability and the engineer team. So we want to have a team of young engineers, given that we observed that there are less and less young people graduate from university willing to accept a compiler engineer job at back in 5 or 6 years ago. And this time, when the AI gets popular, so the AI software stack that gets very hot, so which get the compiler engineer job hot again. So basically, the last 2 item bullets just means that which I'm really good at. We have so we should have hold a lot of meetings, meetups, seminars, workshops, all the event summits, and to let more and more young engineers to learn compilers, to try to write some patch and try to communicate, share it, and go upstream. So that's the vision of the PLC lab. It's all about open source, and we mainly focus on the RISC-V research. So at the beginning, so we want some reputation, and we got to be seen in the world. So because that in order to get more funds, we don't want run out of money again. So fortunately, that at that time the RISC-V International is called for the contributors to develop patches for their draft extensions. So there are lots of extensions. They write a spec. The spec was proposed and discussed and modified again. But the basic software support, especially QEMU, GCC, and Linux kernel and OpenSBI, some roughly half a dozen important softwares, they need to be implemented by software engineers. So I have 20 engineers. We joined the RISC-V International and became the development partners, the training partners. We have a lot of open courses online, free. You can free to access, but it's in Chinese language. So sorry about that. So, and 1 year later, so I think we get enough. We get famous. We get recognized in the RISC-V International, and we want to, or basically I want to do something really challenging. So I checked the website of the RISC-V International at that time. So at the bottom of the front page, there's 2 help wanted project items in here. One is V8 RISC-V porting. So V8 is very important in the modern software ecosystem. So it's embedded in the Chrome or Chromium browser. Basically, it's the engine of the JavaScript. So basically, all your software, all the apps, all the system you run, so they will need JS Web Engine to run the code. Normally, it's V8. Then the other is SpiderMonkey in Firefox. I will introduce later. So the other one is AOSP, if I remember correctly. So let's do it. So my technical director, so which is also the RISC-V ambassador, and fortunately she's able to. She has a poster here. You can discuss to him directly if you want to have some more technical details about the status and the roadmap of V8 RISC-V. So we got done, and very dramatically. So it's after the first release. So we also, when we start the project in the beginning of 2020, so we just announced in a mailing list and say that we are started doing this. Anyone want to join? So we were trying to avoid deployed wars, but turn out. So when we ran through the first Hello World example and we published the source code. Just after 30 hours, so another team we never heard of, the team joined from the Future Wei, which is Huawei in America, the research institute in America, and the RISC lab. They released their code. That's more sophisticated, more mature, and so the leader from the Future Wei, Wu Peng, we hold a meeting and we joined as a joint team to contribute to go the upstream and maintain it. Now, and a year later, the Open found a new job. So he now is an engineer. I think it's maybe a senior role in the PyTorch community. So, and the maintainer of the V8 RISC-V backend is now the Choji. The ambassador is also the director of the PLC lab. So, and the other big thing we do is the Android. So, and again, back to the 2021. So we are trying to say Android is too big to us, but maybe we can bite it or a small piece. So we run a minimal system. We can just run the kernel and has a shell like the BizBox and try to call more people to do the graphic ends. So we announced we will start. We announced that we will do it and have some small progress, and then the interesting and very thankfully the Xuantie team from Alibaba and then the a group of other teams joined. So basically the Xuanqie just released a more complex and more sophisticated implementation for porting the Android 10 or 11 to their TH1520 SoC. So that's basically you can start a graphic interface, and 3 or 6 months later, they successfully get the web browser run on the Android on RISC-V. So it's successful. And 1 year later, if I remember correctly, the Google officially announced that they will support upstream, and basically there's a AOSP SIG in the RISC-V International. I believe that we have many friends that are working on. They are trying to get their chips running very smoothly on the AOSP. So after done the 2 big jobs, so we think we should dream bigger. So we get more funds, and we have more staff and more interns. We have more than 100 interns at the time, and more than 50 staff at the 2022. So basically, I proposed some new projects. So basically, I want a RISC-V laptop, and at that time there's no even Linux distribution, no operating system can run smoothly on it. There are a lot of softwares were absent. So basically, first once given that we have V8, it works very fast. So we want Chromium browser, and we want Firefox. We are really a big fan of Mozilla. The spirit being Mozilla, we support Firefox. So we want Firefox run on RISC-V. And then we add this tool. So we get some feedback from our friend companies. Usually the RISC-V IP or SoC companies. So this adds the OpenJDK is a key to the server side. So we added OpenJDK, and a lot of the engineers, performance engineers, who willing to their job to improve the spec of the chip. So they say that they said to me that they want dynamic real. So it's very important to improve single core performance and to try to some profiling. So we added this to the list. So also the dynamic real, now it's get upstream. You can download the dynamic real and have the basic RISC-V support, and a few tools can be used. If you want some tools that not supported, just a file issue. So we will find our maintainer to get it done. So basically, the PLC lab is about the compilers, simulators, and the language versions. And the task is about the operating system. So we have a more ambitious. That's most of the important moment of my journey to RISC-V. So first, we want all softwares. So that's some brackets. So we just do a tiny bit of it, because that there are 20,000 packages in our Linux distribution. And more than 95% of packages can be just cross-compiled or native compiled to the RISC-V. Only 5% softwares need the engineers to get it done. And most of them, unfortunately to the community, but fortunately to the PLC lab, so it cannot be ported. It's because naively, it's because that there's a compiler and a JIT compiler, just-in-time compilers in the software. So it needs compiler guys, which very rare in the world, to get to the porting. So and the second thing that is we want RISC-V laptops, and we want to get run not only the web browser but also the OA suites, so we can deliver to all the stuff in the PLC lab and even the ISCAS. So the OA suite we choose LibreOffice. So that's most important open source OA software. And the third body is that we want to do also as HPC computing. So I was an observation back into 2022. I believe and I predict there will be more than 2 RISC-V clusters to enter the top 500 HPC list. But we now have 10 months left. So I'm not sure that it can be to be true, but be optimistic. And so LibreOffice done. You can just download it, and it has RISC-V support. And the LuaJIT. So we found that a lot of softwares will depend on the LuaJIT, not the Lua, but the LuaJIT. So also we have a genius intern. She get the LuaJIT port down, but upstream we have some long path to go. You can just search it and find a well-formed downstream repo and get it done. And Node.js, so we get V8 done and Node.js done, but there are some special issues within Node.js. We get some roughly 2 years, along with a lot of contributors from the SUSE and the Red Hat and many other communities to find the bug and fix. And the most time we spent was improve the stability of Node.js. So 3 years ago, so we already have this map. So this map, the upper rectangles is just a list of popular Linux distributions and RTOS I touched, I seen. And the downside is also all the language runtimes. So some of them were just very thin runtime, like C runtime. It's just a bunch of functions. And some languages like Java and JavaScript and Go and Dart, so they get managed runtimes. So the runtimes will manage the memory automatically for the programmers and for the applications. So that's very complicated. They have multiple JIT compilers in it. And basically by the end of the 2022, I said that, well, we already have RISC-V laptops. So the first laptop is, I believe it's the DC Loma. It's not from the ISCAS, but I was very happy to see that RISC-V has such a lovely community, so that now you can buy more than 6 types from different companies, the RISC-V labs, if you want. So, and again, so the front ends, and I ran out of money, so I had to disband the team and say you're fired. So, but this time we are more strong. We're stronger than a few years later. So a couple of engineers and managers in the TASIA program, they just formed a new company called Kubuds. So, and I'm very proud that I get involved into co-founding and provide a lot of startup advisor consultant to how to set up a new company. So basically, that's the journey. So I'm here. And these the founders of the Kubuds. So you may have some impression that the Junqiang on the right side is also the head. So the head of the TASIA project. He once managed all the operating system projects, and the Wei Wu. So the other founder is the head of the simulators, QMU, Gen 5, all the works was led by him. So and now, so this you can treat this as the only advertisement in its size. So basically, so where the TASIA contributed now can support. You can find some support in the open source or commercial support from Kubuds. So, and let's go more higher in a broader view. So why I choose RISC-V as a next a few years. So basically, so I think that the open source community embraced RISC-V. It's very good. But we still need a new project. So this just the Chinese characters. So I think that we need. I can do it within 12 years. So basically, that the commercial success, prosperity, it's for RISC-V. It has a special difficulty. So it's I call it the first mover disadvantage. So because that if a company A we make RISC-V IP and he wants software K to run on it, so he may pay the company K a few dollars, but once the K software can run on the chip that company A sells, so the other companies, company B or company C, so all the RISC-V chip can run the software K. So the first mover will have more costs and less profits. So it's called a disadvantage. So basically, there's the vision I have. So sorry. So it's simple. I think I believe that the audience here. So why we come here? So because that we have the same face. And the mission goals, I have 3 goals. So first is that I want to unite almost more than 100 chip makers and RISC-V IP providers and more important, more than 5 commercial software companies to amortize the cost of supporting RISC-V and optimizing on the RISC-V platform. And second is that we want to provide some open source reference solutions in all the high performance areas. And second, we want to build a network of talents, not only the compiler engineers, operating system engineers, but also the talents in education and in RISC-V IP design and even the EDA area. So we also have open EDA projects. So I shared the same view 2 years ago. So I still the same observations or the axioms I have. So the 3 points is basically drive the first principle that drives all the decisions I made. First, Moore's law on the single thread program, the speed of a single thread program, the view of it, so it's just that. The dense or the number of the semi-transistors increase, yes, but the speed stops. And we also demand, especially the AI, we demand more power, and the software get more and more complex. No one can maintain all the stack. And who can maintain the complex of software is very scarce in the world, and no idea how to recruit them. So that's a bit complicated. Simply this page illustrates why RISC-V is and the only winner in the area of DSA time. So, and the Jiacheng project is a manifesto style. It's very simple. You can just you can even think it a personal project. So you can join freely. Just send a PR to the repo, and now you are in. If you want to quit, you just send a PR to remove your name, so you are quit. So, and given the time, it costs almost zero money to run the project. We just connections. With no infrastructure, we just leverage all the infrastructure provided to the open source programs. So basically, and for the start, the first momentum is PLC lab, then the Kubuds. So for the time limit, I just list all the things that we are really good at. If you have any customers telling that they want the software A run on your platform, but you see that the open source projects lack of the support for RISC-V, just file an issue or write an email to me. So this is just a demonstration how we get funded. Again, this is just the members of the Jiaqing project. They can raise the funds themselves and talk to other members directly. You can you don't need to get anything you don't want. So that maybe puzzles you now. So basically, now we have more than 40 companies joining, and it covers roughly more than 2/3 of all the RISC-V IP deliveries in the world. And also, it increased. And we have some very interesting projects. And for the first, the Louis SDKs, we have a poster outside. And for the second is that introduced and demonstrated by the Guoren from Alibaba. And the third I spoke is a challenge game. So if you're interested, you can just search the website. And I want to introduce the more detail about the recruiting of the internship jointly. So the first, before the internship is called a RISC-V board vendor program. It's simple. I am a big fan of RISC-V. I bought some RISC-V boards, and I bought the new boards. The old boards, so I don't need them. So I can donate, I can transfer it, and deliver to the other guy who has interests. So that's the basic idea. I set up a system to log the process, and I find a few companies, RISC-V members, to cover the delivery fees. So you can just get it, search it on the website. So and it's a kind of a community was building. And thanks to our donors and thanks to the doc-based managers. So it's a doc-based. When a developer wants to donate a board, they can just send the board to the doc-base, and the doc-base will pay the fee of delivery. And when a developer wants to get a board, the doc-base will send the board to the developer, and also again the doc-base will cover the fee. So basically, a new community was built based on the gifts of RISC-V developer boards, and you get the boards. Thank you. So you get boards, and you want you learn something, and you want to try more, and you will contribute back to the open source community. Then we have the the joint recruitment and development of internship. So that sounds weird to a normally HR in company. So, but I successfully get more than 2,000 headcounts allocated, and now more than 650 interns onboarded. They sign the contract, they get mentor allocated, and they write patch and get this back to contribute back to the community. So we now have more than 10 mentors. Some of them are voluntary, some are just staff in the PLC lab and the Kubuds and other RISC-V member companies. So almost all important fundamental softwares we have support, and we are trying to do some positive improvements. And so all the students who are interested, just welcome. So, and if you have some learning records, not only the certificates, but just the learning records of a one student and one chip project, you can just you can just join the joint program. So we have some integration, and also so the translators are welcome. So and this is a more interesting but strange project to the audience. So if you're interested, just can log into to find this link and to try how it works. So it's hard to say that it works now, but I believe that I will, given that we can recognize, it's just recognize new engineers to the RISC-V ecosystem. So now we have we do have more than 17 engineers was endorsed by me. So I endorse that these young talented guys or even or experienced engineers, they have some ability, a list of abilities, such as such. And for the next 6 years of the Jiachen project, we obviously see that there will be the first 50 million normal users, not developers. We'll start to get ready for the normal users, non-developer users of RISC-V, and it just begin. We just start last year, and not enough user page or wikis were created, so the contributions are welcome. So basically, there's board vendors, like the Milk-V or CPID, so who build the RISC-V boards, and they had to have some manuals and get the software updated. So there's some other projects if you're interested. So you see that without too much money, almost zero money. So there's more than a dozen projects was created and running. So I think that's a very interesting experiment. So and I think that all is about the developers. If we can have enough, we can recruit and interest enough engineers to join the RISC-V system and get some enough resources to get self-taught and become the developers who can manage the complexity of softwares. So the RISC-V will go much faster than you ever think. So thank you. So I think I'm run out of time.
We got about 3 minutes.
Mr. Wu, do you have any question to Mr. Wu?
ご質問のある方は挙手をお願いします。
Yeah, and here's my email. So if you have any
Yeah, I actually have one.
Yeah.
So your Jiachen project is something that you're promoting for RISC-V Prosperity 2036, right?
Yes,
That's
exactly.
like a kind of like 11 years later. So
Yes.
yeah. So can you explain very briefly like about what it is? Yeah.
Yeah,
That
so-
you're aiming for.
Yeah, basically the time period is just the old calendar system in China. So we have Shengxiao. So we have we rotate every 12 years, and so it occurs that I have a rough estimation myself. So I see that the servers, RISC-V servers, could they come to the massive produce in 5 years? Maybe hard to guarantee, but will be all the RISC-V servers and HPC in 10 years or 12 years? Definitely. I truly believe that. And how to speed up this the process? So you know that maybe we have some in the non-America. So we have in Japanese and Japan, and we have in China, in India, and in Europe. So maybe we have we have a chance to promote the process. And it never happen if everyone don't build RISC-V servers or chips or the data centers. So basically the project, the basic aim, the core concept is amortize the cost. Amortize the cost of commercial softwares running on RISC-V.
Thank you.
Thank you, Mr. Wu.